Hi everyone, welcome to our last lesson in chapter 7, and it is on 7.6 in our notes. It's called the quadratic formula. This is a great formula to use for any quadratic equation, particularly those ones that aren't factorable, but it can be used on any quadratic equation, and it allows us to find the roots quite simply. Okay, so if you're watching this today, I'd like you to have out your data booklet. So please, if you don't, just pause this now and get out your data booklet. And we're going to be using the very last formula in the chapter 7 formulas, which is the quadratic equation. It's also in the notes, but it's good for you just to see that and know where it is in your data book. So let's get started. So the quadratic formula is a formula that we use to find the roots, which, to remind you, the roots are just a really fancy term for the x-intercepts of a parabola. So the places where the parabola crosses the x-axis, and they're also sometimes called zeros. So we do want to be familiar with all of those terms, and they all mean the same thing. Roots, x-intercepts, and zeros. They're all the points where y is equal to 0. Those are the values of x. Okay. What's really important is when you use the quadratic formula, you have to ensure that you have your quadratic equation in standard form. What you're going to end up doing is using the values of a, b, and c and putting them into this formula here that you see. X is equal to negative b plus or minus the square root of b squared minus 4 times a times c, okay, divided all by 2 times a. So it's really important that you get, if your quadratic equation is given to you and it's not in standard form, you need to get it into standard form, okay, so that you can clearly see what your values of a, b, and c are, because you're going to have to plug those values into the formula. So the first thing you need to do is, if it's not in standard form, okay, get it into standard form. So make sure. Okay, so what I mean by that is make sure your quadratic equation is written in standard form, okay, rather than factored form or just out of order standard form. Get it into proper standard form. So y is equal to ax squared plus bx plus c. Okay, the equals 0 here isn't that important. We're just going to, at the end, we usually, when we're solving for x, we set the whole thing equal to 0. But what we really want to see is just y is equal to ax squared plus bx plus c. Okay. On your data booklet, if you're having a look there at your data booklet right now, let me just pull ours up. Okay. There's the quadratic formula there for you. Okay. And there's that note is actually already given to you. It says the quadratic formula is used on a quadratic equation written in standard form. And if you forget what that is, you come up here. There's standard form right there. Okay. So it's f of x, or y, is equal to ax squared plus b plus c. So that's what gives you the values of a, b, and c, and then you just plug them right into this formula. Okay, so there's a reminder for you there as well. Okay, let's do a couple of notes before we carry on with some examples. The first thing we need to know is that when we use this formula, the values that we're going to get for x, so we're going to plug in a, b, c, and we're going to end up with some number. X is equal to either 1, okay, number, or possibly 2 numbers. If there's 2 roots, only 1 number if there's 1 root. And that's giving us the solutions, the roots, the x-intercepts. That's them. That's what they are. Okay, so we don't have to do any setting equal to 0 here. They're going to come directly out of my formula. The other thing I need to notice is that if the radicand is a term for whatever is inside your square root symbol. Okay, a square root, or any root at all, is called a radical, and so this, okay, this in here, the b squared minus 4ac, is going to simplify to a number, and that number inside is called the radicand. Sorry, the radicand. My spelling is not good today. The radicand. Okay, so whatever that number works out to be inside there, that's called the radicand. And we can't take the square root of a number that is negative. Okay, so it has to be a positive number in there for us to actually be able to take the square root and to get a root or get a solution. So if we go ahead and we simplify that number, and the number inside the square root symbol simplifies to a perfect square. So for example, 16 or 25. So it would look like this, square root of 16, or square root of 25, or some perfect square. That tells you that you could have also used factoring to solve for the roots. Okay, that's all that tells you. So if you do that and you get a perfect square there, your numbers for x are going to be some nice either whole numbers or numbers that would have been easy to solve by factoring. Okay, if the radicand inside that square root symbol simplifies to a negative number, so for example, if you have negative 14 in there, okay, or any negative number, even if it's negative 25. I know that the square root of 25 is 5, but there is nothing that I can, there's no way I can solve for the square root of a negative number, because a positive times a positive will give me a positive, okay, and a negative times a negative will give me a positive as well. So no number multiplied by itself will ever give me a negative value. Okay, only a positive times a negative will give me a negative value, and then those numbers are different. So the term of a square root, that term itself, has to give me a number that's being multiplied by itself, okay, to give me the number inside. So if you get a negative, all that means is that there's no roots. And another way we say that is there's no solution. Okay. Okay. Let's do some of these then. So first of all, here's example 1. It says solve the quadratic equation. And you've got this quadratic equation given to you. The first thing you want to do is get it into standard form. And so standard form is y is equal to ax squared plus bx plus c. So just by looking at this, I can see that there's my ax squared right there. Right? There's my bx. It's a coefficient in front of the x. And the constant is over here, but it's out of order. So I need to get, okay, my equation into standard form. So it is out of order. So let's go ahead and do that. So 145 is equal to 4x squared plus 84x. Okay, and the only thing that's wrong here is that I have this 145 on the wrong side of my equal sign. I need to move it over to the other side. I want it to appear at the end. So I'm going to either export it over, where I change its sign, or you can subtract 145 from both sides. Okay, either way you do it, you're going to end up with 4x squared plus 84x minus 145 is equal to 0. Okay, so y is equal to 4x squared plus 84x minus 45. This is standard form. So now I can label my a. Okay, so the a value here is equal to 4. Okay, there's b. b is equal to 84, positive 84. Be careful to look at the sign in front of it. And there's c. And c has a negative on it, so it's negative 145. Okay, so there's my 3 values. Now we're going to use the formula. Okay, the formula is given to you in your data booklet, and it's equal to x, the roots will come from taking a negative b, okay, plus or minus the square root of b squared minus 4 ac. This is 4 times a times c. Okay, inside, all divided by 2 times a. Okay, so we're going to go ahead and plug those values in now. So x is equal to negative b Well, what's b? Let's have a look. B is 84. Okay, plus or minus the square root of b squared. So again, I'm going to put an 84 in for my b. Minus 4 times a, which is 4, times c, which is negative 145. Okay, all of that's going to be divided by, that's what this sign means, divided by, okay, that's what that means, 2 times a, and again a is 4. So let's go ahead and just simplify our math, and then we can solve for x, and we may get 1 or 2 values here for x. Okay, so if I solve this or simplify, I've got, it's going to be negative 84 plus or minus, let's do the math inside. Well, 84 squared, okay, is going to give me 7,056 minus, okay, now be careful here. If you look up above here, I've got negative 4 times 4, which is 16, times negative 145. So the negative times the negative is going to give me a positive value there. And I have 2,320 as my answer when I do 4 times 4 times 145. Okay, so that's what I have inside. And it's all divided by 2 times 4, which is 8. Okay, let's keep going here. X is equal to, I'm going to put the radicand together, the two numbers inside. So I get negative 84 plus or minus the square root of 9,376, okay, divided by 8. At this point, you can go ahead and you take the square root of 9,376, okay, and here's what I get. Negative 84, okay, plus or minus 96.8, okay, if I take the square root of that and round it, divided by 8. Okay, and so there are now two possible roots, because one root is when I take negative 84 and I add 96.8 and divide by 8. The other root is when I subtract 96.8 from negative 84. And those are going to give me two different numbers. Okay, I'm just going to give myself a clean page, but hopefully you've still got a little bit of room on your page. Okay, so here's my two roots. Okay, so root number 1 is when I have x equals negative 84 plus 96.8 divided by 8. Sorry, I should have my sign right, my line under the 8, negative 84. Okay, and so that will give me, let's see, x is equal to, well, that's going to give me a positive number on the top. And when I divide by 8, my answer is going to come out to be 1.6. Okay, negative 84 plus 96.8 divided by 8 is 1.6. There's my root. Okay, the other root that I have is when x is equal to negative 84 minus 96.8 divided by 8. Okay, and when I do that, negative 84 minus 96.8 gives me a bigger negative number. And when I divide that by 8, I get negative 22.6. Okay, so there's my other root. Okay, and as it turns out there, this one will not be factorable, because this is my radicand was not a perfect square. I didn't get a nice whole number out of that. Okay, so those are my roots, and let's go ahead and try another example. Okay, here's a quadratic equation. 2x squared plus 8x equals 5. Again, I want to start by getting it into standard form. If I'm going to use the quadratic equation, I have to get into standard form. And let's remember what our standard form is, right? Standard form is y is equal to ax squared plus bx plus c. So c is the number that's all by itself. So there's my c, the 5. There's my ax squared there. There's my bx. The only thing wrong with this is, again, that 5 is separated from the other two terms. I want them to be all together. So I do need to move that 5 over to this side, okay, just so that it's coming after the 8x. So let's go ahead and do that. Okay, so we'll get 2x, so y is equal to 2x squared plus 8x. And that's all equal to 5. Well, if I subtract 5, okay, from both sides of that equal sign, or I export the 5 over and have to change its sign when I do that, okay, I'll get y is equal to 2x squared plus 8x minus 5, and that's all equal to 0 because I'm not left with anything on the other side of the equal sign. So there I have it. Okay, A is 2, B is 8, and C is negative 5. Okay, paying attention, if I have a negative sign or a subtraction sign in front of that constant or in front of any term, that gives me a negative value. Okay, so then I use the quadratic formula. Okay, and the quadratic formula is that x is equal to negative b plus or minus the square root of all inside b squared minus 4ac, all divided by 2 times a. Okay, so let's go ahead and plug in those values. So I have 4b, I have 8, so I have negative 8. Okay, that negative comes from the negative in the formula, plus or minus the square root of 8 squared minus 4 times a, which is 2, times c, which is negative 5, all divided by 2 times a, which is 2. Okay, so that can simplify. Let's keep working here. Let's simplify this down a bit. So negative 8 plus or minus, okay, well, what's inside my radicand? 8 squared is 64. Okay, again, negative times a negative. This negative here, the subtraction sign in that negative, is going to give me a positive, okay, inside. And I have 4 times 2 is 8. Okay, and 8 times 5 is 40. So I've got 40 inside plus 40. Okay, all divided by 2 times 2, which is 4. Let's work across the page here. Let's simplify that radicand down. So inside the square root symbol, I have 64 plus 40, which is 104. Okay, and it's all divided by 4. So there, again, now there are 2 roots. One root is when I take negative 8 and I add the square root of 104. The other option is when I subtract this square root of 104. And I'll get 2 different numbers there. Okay, so one root is going to be x equals negative 8 plus, so let's do the addition first. Square root of 104 is 10.2, okay, to the first tenth of a, to the nearest tenth, divided by 4. Okay, so if I do that, x is equal to, well, that's going to give me a 1 point in on the top, divided by 4 is 0.55. Okay, so there's one root. X is equal to 0.55. Over on the other side here, okay, here's my other root. My other root is when I'm going to subtract the square root of 104 from negative 8. So x is equal to negative 8, subtract 10.2, square root of 104, divided by 4. Okay, and this time, if I do that math, I get a bigger negative number on the top, negative 18.2 on the top, divided by 4, which is negative 4.55. Okay, and there's my other root. So there are two roots here. So this parabola crosses the x-axis twice at x equals negative 4.55 and then again at 0.55 on the x-axis. Let's do, I think this is our last example in our notes. And again, this time I've made it a little trickier because instead of seeing x's here, we're seeing p's. Okay, if you see this, p is just a different variable. Instead of x, you're seeing a p. Okay, so maybe it represents something, pineapples or who knows, something that starts with P. It doesn't matter. If you wanted to replace it with X, you could. Okay, so you could call that X squared and that would just be the X instead of P. And you could go ahead and do that. Okay, it really makes no difference. I just want to show you something, a quadratic where they're graphing some variable. Okay, P versus, who knows, maybe Y, maybe something else, okay? Could be population, we're not sure what that P stands for. But you can either change it into an X to make it easy for yourself, or you can keep it as a P. It really makes no difference at all to using the formula. Okay, just know that X is P. Okay, so if you wanted to replace it with X, we could do that. So let's go ahead. So in standard form, hopefully you're getting really good at standard form now. I see that it's already in standard form, so that's great. Okay, if it wasn't, I'd have to rearrange it. So it's in standard form, so now I can identify, I'm going to rewrite it like this. 6x squared minus 123x plus 725. So I'm just going to replace the variable. Okay, that's equal to y, which I've set to 0. And so again, I can figure out my a, b, and c value really quickly. Okay, a is equal to 6. There's b. B is equal to negative 123. Be careful. And c is equal to positive 725. So we've got some pretty big numbers here. And let's go ahead and use our quadratic formula. Okay, so x, or p, is equal to negative b plus or minus square root of b squared minus 4 times a times c, all divided by 2 times a. Okay, and let's go ahead and plug in our values. So we have, this time b is a negative number. It's negative 123. So I have a negative sign in my formula, and I'm going to also have a negative sign attached to my b value here. So a negative times negative is going to give me a positive. Okay, plus or minus square root of, okay, I've got negative 123 here for b, but I'm going to square that, which is going to cause, that's going to give me a positive result. A negative number multiplied by itself is going to give me a positive value. So b squared will be a positive number. Okay, minus 4 times a, which is 6. Okay, times c, which is 725, pretty big number. All divided by 2 times a, so 2 times 6. Let's go ahead and simplify this down a bit. So negative 1 times negative 123 is 123 positive. Okay, plus or minus. Okay, inside I have 123, negative 123 squared, which is 15,129. Okay, subtract 17,400. Okay, all divided by 12, because 2 times 6 is 12. Okay. What we can recognize right now, we can continue to do the math, but I noticed something. The number here, okay, 17,400 is bigger than 15,129. So when I do that subtraction, I am going to end up having a negative number, okay, because we are subtracting a bigger number here. So at this point, you can already start to predict that I'm not going to be able to solve this. I'm not going to have a positive value as my radicand. So, but let's go ahead and just prove it. So 123 plus or minus, let's do the subtraction inside the square root symbol. It's going to be negative 2,271. Okay, all divided by 12. So at this point, you cannot go any further because you cannot take the square root of a negative number. Okay, so the radicand is negative. Okay, so we cannot, okay, take the square root of a negative number. There's no two numbers multiplied by itself that will give me a negative number. Okay, because a positive times positive will give me a positive, and a negative times negative will give me a negative. So there is no solution to this problem, which means, okay, if I can't get a solution, no real solution, okay, there is no root or roots plural. Okay, great. I'd like you to try some of these for yourself. I think once you do a couple, you'll find that they're pretty simple to use. And again, remember that you have the quadratic formula in your data booklet. I'd like you to try questions on page 427, numbers 1 to 4. For question number 1, you can simply just solve them. Okay, I think number 1 is a little bit of bit more complex. I think I might ask you to graph it as well, but for now we can just solve. I just want you to practice using the quadratic formula. We've already done some graphing. Okay, so just solve for number 1, and then you can do questions 2, 3, and 4. Side note on question 4, okay, if you're checking the answers in the back of your textbook, which should be, you'll see that the solution that's given for some of the answers in 4 has been simplified in a different way. So in other words, it's just been left as a fraction. When we take the square root, okay, of a number, if that number is, I'm just trying to think of an example here. Okay, like for example, 17. For our purposes in Math 11, we can simply square root that number and then just round the answer. Okay, what the textbook is doing is they're trying to keep it as exact as possible. So if they can't get a whole number here as an answer, so if it is a decimal, they're simply just writing their radical here as a mixed radical. Okay, so they're just pulling out any perfect square that they can from it. So for example here, 17 isn't a very good example. Maybe I could do something a little bit different, like 27. Okay, would be a better one. So 27, they're just thinking about it like, well, 27 isn't a perfect square, but 9 times 3 is equal to 27, and that 9 can come out. So that's the same as 3 times whatever's left over, which is the square root of 3. Okay, so they're just writing it as a mixed radical, and then they're leaving their answer like that. For our purposes, to keep it simple, we want to get as close to a value of x as we can. So we can go ahead and just, for our purposes, we can just square root 27 and leave it as 3 point something, okay, as a decimal place. But otherwise, you should be getting the same answers as the book. You just may see that they present their answer in a slightly different form. Okay, so good luck, folks. That's our last lesson. So I hope that you find this last part very clear, and good luck studying for the Chapter 7 test. Bye for now.